All right, let's dive in. Today, we're going to tackle one of the absolute trickiest parts of thinking for anyone. How do you separate what is happening from why it's happening? This is all about the journey to true causal thinking. So, let me kick things off with a classic riddle for you. It's a fact that when ice cream sales go up, so do shark attacks. They rise at the same time. The question is, does eating ice cream somehow cause shark attacks? No, of course not. That sounds ridiculous, right? The real reason is a third thing you can't immediately see: hot weather. When it's hot, more people go swimming, and, well, more people buy ice cream. But this simple little puzzle, it actually points to a massive challenge. Seeing that two things happen together is easy, but understanding why, the actual cause, is incredibly difficult, not just for us, but for even our most advanced AI. And this gets us right to the heart of what we call the causation challenge. It's all about learning to move beyond just seeing simple patterns. And this is where we have to get really clear on a crucial distinction. On one side, you've got correlation. That's all about prediction. It's noticing, hey, these two things tend to show up together. But on the other side, you've got causation, and that is all about control. It's knowing what lever to pull to actually make something happen. One lets you place a really smart bet on what's next. The other lets you step in and change the outcome of the game entirely. So, how do we make that leap? How do we get from just predicting to actually controlling? Well, there's a really powerful mental model for this from the computer scientist Judea Pearl. He calls it the causal ladder. Basically, what this framework does is it organizes our thinking into three levels, and each one gets more and more powerful. The bottom rung is association. That's just seeing patterns, what we've been talking about. The middle one is intervention. That's about actively doing something, running an experiment. And the top rung, the most powerful of all, is counterfactuals. This is the uniquely human ability to imagine different realities, to ask what if. So let's boil it down to three simple words: seeing, doing, and imagining. Here's the crazy part. Most of modern data science, and frankly, a lot of our own day-to-day intuition, gets stuck on that very first rung, just seeing patterns in the data. The real magic, the real breakthroughs, they happen when we start to climb. Okay, let's make this super concrete with an example all of us can probably relate to: a dying houseplant. On rung one, association, you just see things. The leaves are yellow and the soil looks really dry. Rung two, intervention, is when you do something. Okay, what happens if I water it right now? You're testing a hypothesis. But rung three, counterfactuals, that's the highest level. You come back, the plant is dead, and you ask yourself, if only I had watered it yesterday, would it still be alive today? That question, that ability to rewind time in your head, that is the absolute key to real learning. Now that we have this framework, let's apply it to one of the biggest fields out there right now: teaching machines to think. Because it turns out that AI researchers are trying to get machines to climb this exact same ladder. And for AI, this ladder has a really direct parallel. At the bottom level, an AI has a map. It just understands how things are connected right now. At the second level, it has an orrery. You can think of that like one of those old clockwork models of the solar system. It can predict where the planets are going to be. But the final goal, the top rung, is a simulator. This is an engine that can answer those deep what-if questions and actually explore alternate realities. And that simulator, well, it's pretty much the holy grail of AI research right now. And you might ask, why? Why is it so important? Because giving a machine the ability to truly imagine alternate realities, that requires a genuine understanding of the world that goes so far beyond just matching patterns in a bunch of data. It's a whole different level of intelligence. And what's fascinating is there are two totally different philosophies on how to get there. On one hand, you've got the traditional AI approach. It's basically searching for the one true causal graph of the world, assuming that the rules are fixed and never change. But then there's this other approach called NARS. It believes causality is actually subjective. It's a tool that helps an agent adapt to its environment, an environment where the rules themselves can change over time. So instead of being programmed with all the answers from the start, a system like NARS learns about the world kind of like a curious little scientist. It's constantly running experiments, that's intervention, and then it thinks about what could have happened differently if it had done something else, and that's counterfactual reasoning. It literally builds its own understanding of why from the ground up through experience. Okay, so that's the world of AI. But what's really amazing is we can now turn this exact same lens back on ourselves and understand what's going on inside our own minds.
So, psychologists often talk about our brain having these two different modes of operation. You've got system one, that's your fast, automatic, gut reaction thinking. It's basically always on. And then you have system two. That's your slow, deliberate, analytical mind. And the thing about system two is it's kind of lazy. It takes real conscious effort to fire it up. And here is the aha moment. Here's how this connects directly to the causal ladder. Our fast, intuitive system one, it's a rung one machine. It is brilliant at spotting patterns and making quick associations. But to climb any higher, to actually intervene or imagine what if, that requires our slow, lazy, deliberate system two. And here's the problem. Our brain wants to save energy. So if system one gives us an answer that just feels right, we often never bother to do the hard work of engaging the more powerful, logical part of our mind. What this all means is that our default mode of thinking keeps us stuck on the bottom rung of the ladder, just seeing correlations. To get to true causation, to really understand cause and effect, we have to consciously, deliberately make the decision to do the hard work, to engage our analytical brain and start climbing. So, let's bring all this together. We've talked about AI, we've talked about our own brains. Why does all of this matter so much?
Well, the big takeaway here is exactly the same whether you're human or an AI. True, genuine intelligence isn't just about describing the world as it is. It's about being able to explain it. That journey from just seeing what to truly understanding why is the path to mastery. It really all comes down to this one powerful idea. True intelligence isn't just knowing what is. It's understanding what could have been. I mean, that's it. That is the very definition of climbing all the way to the top of the causal ladder. And that leaves us with a final, and I think, pretty fascinating question to think about. As we get closer to building machines that can finally climb this ladder for themselves and start to ask why, what are the truly important questions that we, their creators, should be asking them?